Okay, as I said, if you've just joined, you can mute your mic. Then, if you have any question along the way, feel free to ask. Okay, so we'll answer this question and we'll build up our understanding on vectors on based on this question, which is question 5 of the tutorial sheet. So we have this question and it reads: the diagram shows vectors acting at a point O, which is here at the center. Then they're telling us to find the direction and the magnitude of the vector sum A plus B, the vector difference A minus B, and the vector difference B minus A. So we are told to find that. What are we going to do? So before we answer this question, we first must understand some key terms. So to begin with, understanding what is a vector, because we're talking of vectors here. So a vector is just a physical quantity that has a magnitude. By magnitude, we mean it has what? It has size. This has size and it has direction. It has direction. So a vector is just a physical quantity that has both magnitude and direction. So for it to qualify to be a vector, those two must be what? Must be there. That is the definition of a vector. Now, when it comes to vectors and when we're dealing with vectors, like the ones which we have here, when it comes to the addition of vectors and when it comes to what the vector difference when finding those here, we do these in terms of what? Of components. So what do I mean? So as you can see, you have your x or y plane that is like that. And we have our y there and our x-axis there. So when I have a vector here that is like that, this vector, let's say it's a vector A. So as you can see that my vector A, they have put an arrow like this. So this is how I denote what? A vector. It can be an arrow like that, or it can be something like this. So this also represents what? A vector. So now I have this vector A here. So this vector A has components in the y and in the x. It has a y component and an x component. So as we are locating this vector, there is some component of this vector that is displaced in the x direction and another which is displaced in the what? In the y direction. And those are the components of what? Of this vector. And we are going to denote the components of this vector too by, so ax just to mean that the component of the vector A in the x direction and ay the component of what? Of the vector A in the y direction. So ay is just the y component of the vector. Then I have ax, which is just the x component of the vector. So this is how the vector is what is represented. So now we need to take note of some key, I can say some key formulas here which we will use to solve this question. So one of the key formulas that we're going to use is, so we're saying that this vector is at an angle. So let's say this is our angle theta there. So when we are dealing in terms of finding the x component, so I have the x and the y component. So when I'm finding the x component of the vector, I will use the formula. So to find the x component, I'll say the x component of the vector A is going to be equal to the magnitude of the vector A, which is just like that, the size of the vector A. So the size of the vector A is just given by this, the length of the what? Of the arrow which is displaced. So the length of this arrow from here, the midpoint where it started, all the way up to that side. So this here is going to be what? To be the vector what? A. The length there, the magnitude of that is the this part here which I've written. So then what follows is you write cos theta. So this here is going to be the formula that I'll use to calculate the component of the to calculate the x component of the vector A. To calculate the y component of the vector A, I will say the magnitude of A, then sine theta. So these here are going to be what? The formulas that I'll use to calculate those components. Then, when I am dealing with vectors, what we do when we're dealing with vectors is we add these vectors. For example, where we have there in the question, they're telling us, the first part, they're telling us to find the vector sum A plus what? A plus B. So, meaning there's a vector A and there's a vector what? B. So when you have a vector A and a vector B like this, and that you're adding these two vectors. So what you do is, when you're adding these vectors, you're going to add them component-wise, which means that you add the ones that are in the x-axis together and the ones in the y-axis together. So what do we mean? So if I have a vector A like this one, this vector A, I know it has a what? It has an x component, which is represented as ax, and it has a what? A y component like this, a y. So same even with this b vector here, it will have uh, an x component, also a y component. So when it comes to the adding of these two vectors, what you do is you're going to be adding their components, meaning you'll be adding ax plus bx like this to find the resultant vector in terms of x, like this. So the resultant vector is just the outcome that you're going to be getting when you add those two vectors. So notice that there is a resultant, the resultant vector in the what? In the x. So this is the resultant vector for the x components of those vectors. Then when you're dealing with y, you have y plus by like this. And when you add this, this will just give you the resultant vector in the y components, for the y components. Then to finish up, when finding now your resultant, which I have, the resultant, so we're saying your resultant, which is, we're just going to call it R in this case. So the resultant R, which is of A plus B, A for the vector A plus B. So saying for this vector A plus B here, which we're saying, we say this is R, and this is going to be given by, so you are going to square the resultant x component and you add it with the square of the resultant y component like this. And this here is going to give you your final vector. This is going to give you your final vector for A plus B. Another thing that you must notice is when you're dealing with this, you are also taught to find the direction. And the direction is given by the angle which is there. So to find the angle, you always say tan theta must be equal to the resultant y component, that's Ry, over resultant x component like this. And of course, this just simplifies to, okay, let me erase this part. So this just simplifies to, you have theta being equal to tan inverse of Ry over Rx like this. So this here is the angle that you're going to get. And depending on where your vector is being displaced, you will notice where it's going to sit in the quadrant. So you understand it better as we are going to do the question. So that's what you must have in mind as we are going to get into this question. All right. So now let's go directly and begin to solve this question here. So how am I going to do this question? Uh, okay, just all right. So to do this question, so they're telling us to say we must find the direction and the magnitude. The magnitude is the size, the direction is the angle. So now we are finding the vector sum A plus B. A plus B is the vector sum which we are finding. So now, how you do this is you have to get, meaning you have to have, so as we said, for our vector A, we must find the components of this vector, and for our vector B, we also must find the components of this vector. So, meaning you have to find AX, meaning that's the X component, and it will be given by the vector A cos theta. So now, my vector A, the magnitude of the vector A, as you can see in the question here, it's given. This is 3.6. So that is 3.6. It is given there. Then cos theta. So theta is my angle. So the angle is always measured from the x, from the positive x-axis until you reach that vector. So as you can see here, starting from here, this is the positive x-axis until I reach that vector which is there. And this angle here, it's been given in the question, and that is just 70 what? 70 degrees. So meaning this here is going to be 70 degrees. Notice that it's very important to understand that the angle always is measured from from the positive x-axis until you reach that vector. So this is what we do to get that component. Then to get the y component, we do 3.6. Then we're just saying sine 70 degrees. So now let us compute that. So I have 3.6, then I'm saying cos 70 degrees. And that there is going to give me, so, okay, just a moment. So here I'm going to get, this is going to be equal to 1.23. I'll just write it to 3 decimal places. That's gonna be 1 there, like that. So this is what I get. Then I can do the other one as well. So when I do 3.6 sine 70, 3.6 sine 70. Okay, so 3.6 sine 70 gives me, this will be 3.38, then I get 3. So this is what I'm going to get. So this is my uh, x component, and there down I have my y component. And I must do the same for the vector b. So for the vector b, I have bx like that. So I'll do the same. What is the magnitude? The magnitude have been given in the question. It's 2.4. So the magnitude is 2.4. Then I'm saying cos. Then what is my angle now? So I said the angle is always measured from the positive x-axis until you reach that vector. So we measure from here the positive x-axis until we reach the vector b. And the vector b is there like that. So we see that it has moved all the way up to here like this. So now from this halfway, this semicircle, we know that a semicircle is just going to add up to 360 degrees. Then I have this 30 degrees here, which is the angle in the third quadrant, which leads up to the vector b. So meaning to get my angle, I'll add plus a 30 there. And this here is going to just give me a 10 degrees. So that is gonna give me 10 degrees. So that is my angle at which the vector b is what is displaced. So meaning here as I calculate, it will be 2.4 cos 10 degrees. 2.4 cos 10 degrees. And this here is just going to be, so I can compute that 2.4 cos 10 degrees. And that there is going to give me, so there it's gonna give me negative 2.078. So that's what I get. Then I do the same for by. I do the same for by. So what is it going to be? So for by, I will say 2.4, then I'm saying sine 10 degrees. So 2.4 sine 10 degrees, 2.4 sine 10 degrees. And that is going to give me negative 1.2. Negative. So this is going to give me negative 1.2. So these are the components now that I have for the everything. These are the components that I have. So now what am I going to do with these components? So I can write them. Let me summarize them. I write them properly. So let me write them here on top. So here on top, I write AX to be, this is 1.2 and 3, 1. Then I have BX to be equal to negative 2.078. Then I have here AY to be equal to 3.383. Then I have by here to be equal to negative 1.2. So those there are my components. So then let me erase this. So when I erase this now, here what we're going to do is we need to find now the resultants. So the resultant in the y, in the x I mean, first of all, we find in the x. So this here, the resultant is going to follow exactly what is given here. So what is given there is a plus what plus b is what we are adding. So I'll add the components there as they are. So I'll add a x like that, then plus b x like that. So now when I add these two, what am I getting? So I have 1.231, then this other one here I have plus, then I have a negative 2.078. So this is what I have there. And this, of course, is just going to give me, when that positive multiplies with a negative, to just be negative, and I'll be subtracting. So I'll be subtracting 2.078 from 1.231. So that is just going to give me, I subtract that, I'll just get, so that gives me negative. This gives me negative 0.847. 0.847. So that's what I get. Okay, then I do the same now for RY. So RY is going to be, so I get the same RAY like this plus BY like that. So when I get that, then I'll say my A there, my AY is 3.383. Then my BY is just going to be now negative 2.1 like that. So I'll have 3.383 minus 1.2. And that there is going to just give me, this will be equal to 2.183. 2.183. So that's what I'm going to get there. So these are my what resultants for that. But now, how do I find the resultant vector now? So the resultant vector a plus b, and I'll just give it, say this a plus b is equal to what? To r, such that I say r is going to be equal to, so as we said, r is going to be equal to, we square rx, the component there, plus ry squared. And this here is what is going to give me r. That is what is going to give me what? My final r. So me erase this part here. Okay. So now, having that, we have, so our r is going to be, we can replace there. So the first part, negative 0.847, then squared plus, I can add the other one, which is see here down, the 2.183, then I square that. Okay, so I square that. So now let me erase this part down so that we have space to clean that up. So when I compute everything, let me do everything there. I compute everything, I put it in my calculator. So I have I have negative 0.847 squared plus 2.183 squared like that. Then you add those, then you put the square root, and this O is just going to, after you evaluate your root there, R is just going to be equal to 2.34. 2.34. So I've rounded off to 2 decimal places. And of course, we are using meters. So this is our resultant vector, which is A plus B. So now, this A plus B can be written. So the A plus B can be written. We can write it, or we can write out that. So how do we write that out? So as we said, so we had first of all, like this, we had first of all our vector. we had one vector which is going in the negative direction, which is negative 0.8 something there. So it's going to be here. So our vector is going to go from here up to there. So when we are dealing with vectors, we write them head towards to head. What I mean is from here where we've ended here, we've written our vector like this and we've written our arrowhead. So from the center up to there, where we've ended here, that's where we want to continue. And the other one is what is a positive number. So it's going to prove in the y-axis, it's positive 2 point something. So it's going to move like that. Assuming that here, that's where the 2 point something is. And there, that's where the negative 0 point something is. So when you have these 2 points like this, you connect, meaning from the midpoint or from the middle, from where you started the origin, up to the last arrowhead, which you had like that, you connect there. So this here is our resultant vector, and our resultant vector is the one which we found as 2.3, uh, 2.3 what meters, 2.34 meters, 2.34 meters. So you can notice that the resultant vector here, which you have, is the hypotenuse. So the hypotenuse always has to be longer than these other two what adjacent sides which you have. So we have this one negative 0 point what and the other one 2 point something, but we see that 2.34 is longer than all of them. So this is how it's going to be. Then the question does not end there. It tells us to also find the direction. We've been told to find the direction of this vector. So we've drawn the vector, sketched the vector. That's how the vector is. But now we must still find the direction. So, and the direction of the vector starts from, so the direction of this vector is going to start from the positive x-axis until we touch that vector. So if we start from here all the way up to what there like that. So that is going to be my direction. So now how do I find that direction? So I'll say, as I said, my formula to say tan theta. Okay, so I've used tan inverse, just a moment. Tan theta is going to be equal to the resultant in the y divided by the resultant in the what, in the x. So meaning theta is just going to be equal to tan inverse of the resultant in y divided by the resultant in x, like that. So now how do I get that? So I can replace that because I already found those things. So I have tan inverse, the one in y, which one is my y? So I can go back to this slide. This one here was the one which is for y. So it's 2.1, that's 2.183. Then I have the other one, negative, so divided by negative 0.847, like this. So this here is going to be my angle. So tan theta is now going to be, so I can compute that, place that, I have 2.183, then divided by negative 0.847, like that. And I'll just get that that is going to be equal to negative 2.47733, going that all the way like that. Then I can get the tan inverse of that. Okay, and I'll get that. So this here, when I plugged in, this gives me theta equal to, so the angle is negative 684 point. Okay, let me just do that again. So we had 1.83 divided by 0.847, like this. And so this here multiplied by, so we're saying this is negative. The answer which we're getting there is negative. And we are saying tan inverse of that. Okay, just tan inverse of that, and we just get the same one as we did. It was accurate, which is 68.79, and I can just write this as 68.8. Just round off angles to one decimal place like that. So that's the one that I'm going to be getting. That's the value that I'm going to be getting. So now here I'll check my my quadrant. So I have to check my quadrant. So if I have this negative angle here, I see that the first angle starts from the angle which it has to be displaced. That starts from here, the positive x-axis, and goes up to the second the second quadrant. So when we talk of terms of quadrants, we have the first, the second, the third, and the fourth. So where our vector is sitting in the what? In the second quadrant. So it's sitting there in the second quadrant. And as it is sitting in the second quadrant, the angle is moving from there, the positive, up to there. So this angle which we found, the negative angle which we found, is this small angle here, the inside angle, which is this one. We found this angle here. So to find the other angle, we just say we know that this here almost makes a semicircle. And what we do now, the semicircle, we know it adds up to 180 degrees. So we say that will be 180 degrees, then minus or plus that angle which we found, which is negative 68.80. And this here is just going to give me 180 degrees minus 68.8, like that. Okay, and this here is going to give me 111.2 degrees. So this here is the angle at which this vector is what is displaced at. That is the angle at which the vector is displaced at. Okay, so I don't know if I have any questions on this part. So the conclusion of what we found, let me just write it clearly down here, and I write it in red. So the magnitude we found to be equal to 2.34 meters, and we found our direction to be equal to 111.2 degrees. So this is my answer for part A of the question. I don't know if we have any questions here as we move on to part 2 of the question that's there. Okay. There's no question, so let's move on to part 2. Okay, so when it comes to part 2, we'll be using the same values here which we had. So we've already found our components. So we found our components, and now they're just telling us to find the difference, that is A minus B. So we'll do the same. So the resultant in the x is going to be given by, so that would be AX minus BX, like this. And this is going to be, so what is my AX? My AX is 1.231. Then my BX is minus there, so I have a minus there, and my BX is negative 2.078, like that. And here I multiply the negative by the negative, I just get a positive, and that will be plus there, and I have 2.078. So I have that there, and I can add those two. I have 1.231 plus the 2.078, like that. And I just get this here to be equal to, so this will be equal to 3.309. So the resultant x is equal to 3.309. Okay, now we do the same. We found the resultant in y. So resultant in y, so that will be ry is going to be equal to ay minus by, like that. So ay is My AY is 3.383 minus the BY is negative 1.2, like that. And this is going to give me 3.383 plus 1.2. And I'll get 3.383 plus 1.2. This is going to be equal to 4.583. Okay, 4.583. So this is my RY. This is my resultant for the RY. So now how do I get the resultant vector now? So RY, I write it here to be 4.583. So my resultant is just going to be, I'll say R is going to be equal to, so I'll square these components here. Excuse me. So I'll have 3.09 squared plus the other one, which is 4.583, then squared, like this. So computing that, I have 3.309 squared plus 4.583 squared. So that is just going to give me, this here gives me, okay, my R to be equal to 5.65. So I've rounded off to two decimal places. So this here is going to be my resultant. So I found my resultant. Next, I need to find my what? I need to find my, I must find my, uh, I must find my direction, of course. Must find my direction. And my direction is just going to be tan inverse of what? Ry divided by R what? Rx. So meaning theta here is going to be my RY. My RY is 4.583, then divided by my Rx is 3.309. And of course, we're saying tan inverse of this. Tan inverse of this. Okay. So that will be 4.583 divided by 3.309, like that. So then I'll just get tan inverse of that is going to be equal to, so this here gives me my theta to be equal to 554.170, like that, 54.170. So if I write my vector, so let me draw my vector. I'll erase this part here. So having this, I can round it off further just to, in fact, like that, to the nearest decimal place, like that, which is 1. Then this will be like 54.10 degrees. So writing this vector, drawing out the vector, I have my x and I have my y and my x component there. So when I draw out this vector, I'm going to have that. So Rx, like this here, it's going in the x direction. To go like that, then y, it's going to go up because that's positive y. Then connecting from the center up to there. So my angle is from there until I reach that vector, like that. And I see that this here is an acute angle, meaning it's less than 90 degrees. And of course, it's just that angle which I've found there, which is 54.1 degrees. So that is my direction in this case. So my direction, so magnitude we found to be 5 point, according what we found, yeah, 5 point something. Then we found our direction to be theta to be equal to 54.1 degrees. So this here is going to be my magnitude and direction. Okay, then for the last question here, I'll just do the same. I'll do the same in the same way, in the same manner which we were computing. So erasing those, I'm going to get Now here I'm just doing I'm doing b minus what? B minus a. Meaning the resultant in x is going to be equal to, I get my bx like this, then minus a y like that. And this here is going to be equal to, so my bx is what? My bx is negative 2.078. Then my a source is supposed to be ax. My ax is going to be minus 10 minus 1.231 like that. So I'll just get that is going to be, so 2.078, then saying that is minus 1.231, and that just gives me, so this here gives me the same thing. This gives me 3.309. And when I do for the second one, ROI, I observe that I'm just going to be doing this here minus that one, and I'll be getting just the same answer I got previously, which was 4 point. So when you added that, we got 4.58. So this is going to be my ROI to be equal to 4.583. So what you just notice about this is, so as you've seen, there's nothing that has changed. There's this here and the other one there, and now when you do the same, do the resultant, you're just going to get the same thing which we had gotten in the first place. So this is what you do here, and this is how you proceed when it comes to answering of these vectors. I don't know if I have any questions. This is where we end with answering of these questions on vectors. Are there any questions? Okay, silence means we are together.